Hello. In this video, I'm going to be giving some quick thoughts on titles 4, 5 and 6 for the May 2025 TOK essays. I'll be making individual videos for each one, so do subscribe if you want to catch those, and I'll be putting full-length written guides in the description below as soon as possible. Okay, the first one is number 4. Do the ever-improving tools of an area of knowledge always result in improved knowledge? And for this one, you can talk about whichever two AOKs you like. We'll start by defining a couple of key terms. So first one being ever-improving tools, which refers to any new technologies or systems that help us to maybe gather, analyze, or apply knowledge. So things like advanced scientific instruments, the use of AI. And I'd also pick out improved knowledge, which means gaining a deeper or more accurate understanding of a topic. So yeah, this question is basically, do better tools always equal better knowledge? Now, to answer this question, we need to consider examples of advanced tools in different AOKs. So in the natural sciences, you can think about how super resolution microscopes allow scientists to see structures at a much smaller scale than ever before, which leads to discoveries in cell biology and nanotechnology, which were simply impossible with older microscopes. And yeah, this is a clear example of how improved tools can advance knowledge, literally revealing things that we couldn't observe before. Now, in history, tools might include the digitization of archives or perhaps the use of machine learning to analyze and process historical texts. And these developments have certainly made it easier for historians to access and cross-reference large amounts of information. And this in turn might lead to new insights and connections that were previously hard to uncover. So yeah, the focus of this title is, do better tools always equal improved knowledge? So this isn't necessarily the case, because sometimes an overdependence on new technologies might actually limit the scope of understanding by, for instance, narrowing the scope of research or even missing important details. Also, human judgment does play a key role, so even with the best tools, how we interpret and use the information they provide determines whether knowledge really improves. Okay, Title 5. To what extent do you agree with the claim all models are wrong, but some are useful? And for this one, you have to talk about mathematics and another AOK. So, breaking down some key terms first. We'll begin with models, so simplified representations of complex systems or phenomena, and they help us predict or understand how something works, but they don't capture every detail of reality, of course. We can paraphrase the second term slightly as wrong but useful, which means that even though models aren't perfect and don't represent reality, as I said, exactly, they can still be valuable in the sense that they can help us to make predictions, guide decisions, and also improve our understanding of how things work in general. Now, let's define what a model looks like in the context of a couple of AOKs. So, for instance, in mathematics, specifically applied mathematics, a model could be an equation or a graph which represents anything from predicting population growth, measuring the spread of a disease, any other real-world situation. And the purpose of such models is to help us understand trends or patterns without showing every single factor involved. Now, in the natural sciences, along similar lines, models can include things like climate change or simulations that predict weather patterns, and they simplify incredibly complex systems to give us useful insights, although, of course, they can't predict every outcome with perfect accuracy. And on this note, yes, every model has limitations. No matter how good one is, it can't capture every tiny detail of the real world. But even with these limitations, they can remain valuable because they simplify complex systems enough for us to understand and perhaps use to make informed decisions. There can, of course, be a trade-off between how accurate a model is and how useful it is, because the more accurate a model tries to be, the more complex it becomes to use, generally speaking. But if a model is too complex, it might be too difficult to use or understand. On the flip side, however, a simpler model might be easier to apply, but not so precise. So yeah, we have to balance how detailed and realistic the model is with how practical and easy it is to use. So this title is about weighing the usefulness of models against their limitations. While some models might be too far from reality to be useful, others may still hold immense value even if they aren't perfect. It just kind of depends on how they're used and in what context. Okay, coming on to the final title. Does acquiring knowledge destroy our sense of wonder? Quite a dramatic title. So let's start by defining the key terms. The first one I would pick out here is sense of wonder, so that kind of feeling of awe, curiosity, or amazement when faced with something unknown or incredibly complex. And I'd also highlight acquiring knowledge, so basically learning and discovering new information. Now, to understand this question, we first need to think about what a sense of wonder feels like in different situations. It's kind of that amazement you feel, as I was saying, when you see something the first time or you don't fully understand how something works. But does learning about it always take away that wonder? Or perhaps, on the other hand, does gaining knowledge make things even more fascinating by revealing deeper layers? So let's put these questions in the context of a couple of AOKs. In the natural sciences, gaining knowledge could sometimes reduce wonder. So, for example, understanding the physics behind how a rainbow works might take away some of the magic you experienced when you saw one as a very young child. But it can also lead to more wonder, perhaps, because when you learn about how light interacts with water droplets and how different wavelengths create different colors, you might find yourself even more amazed by the beauty and intricacy of nature. In the arts, gaining knowledge can also work both ways. So, let's take films as an example. When you watch a movie for the first time, you might be wowed by the story, the visuals, the emotions. But if you then go and watch one of those behind the scenes videos with actors just hanging out on a studio set without any kind of special effects or editing techniques involved, some of that amazement you felt while watching the film might fade. On the other hand, knowing what goes on behind the scenes, like the skill and creativity that went into producing the film, this could actually increase your appreciation for it, and you might become more amazed by the artistry involved. So yeah, an important point to remember here is that the connection between knowledge and wonder could vary greatly within AOKs and certainly among people experiencing it, because of course what fascinates one person might not have the same effect on someone else. Okay, so yeah, those were just some initial ideas for the titles 4, 5 and 6. I'll be making more detailed ones for videos for each, as I mentioned before. So do let me know in the comments if there's one that you want me to cover first. I will get around to all of them, but I'll prioritize any which appear below. Okay, thank you very much for watching.